Hello everybody. So today I'm going to explain you the division, I think atcoder beginner contest 438, and I will going to explain you the 5 problems. Okay, so let's start. So basically in this problem you have like a year has 3 days and contests are held every 7 days. So basically what you have to do is every contest will happen in the 7 days. Okay, that is fixed. What you know that the first contest in that year will happen in the this 5 day. Okay, means I'm explaining you. If you have a year 0, 10 and 20 means this is your 1 year, this is your 1 year, and the contest, if the contest is happening at the fifth, means the first contest will happen here and the next contest will happen after 7 days, which is 12. So you have to just tell this value, which is 2. So you can see the answer is 2. So what the solution is, simply you can see think, if this is value of f, so solution will be f plus n into 7. Okay, means, so basically what is this, modulus 10. Okay, so this is a solution. So basically you have to find this value, when this value exceeds 10, and you will do the modulus with the like x, you can see here d. So d, so this will be your answer, means you have just increased this value, take the n from 0 to n, because you can brute force, as you can see the d and values are very slow, so you can just brute force and increase this value till that this exceeds d, and when it exceeds you can simply print the modulo. I didn't code that because I didn't give this contest, so you can just try it yourself. I think I had explained well. Okay, so now just read this problem. So this problem is saying, this problem is again easy. So this problem is saying you have given a string n and m, something something. You can read here, okay, 0 to 9, and you can perform the following operations 0 more times. Choose one character from t and increase the chosen digit by 1. However, the chosen digit is 9, change it to 0. And you can do something like contiguous subsequence of something. Okay, so you can see again the constraints are too low, means they want brute force from you. But let's see what kind of brute force they're asking from you. So if you simply see what they're asking, suppose you have a string s. Sorry, don't know why, but now right today my mouse is not working fine. S, my mouse is, wait, okay, so you have s and you have t. Okay, so see, I'm just explaining you. So you have 2025, okay, and 91. Okay, 91. So what is they saying, you can increase the characters from 9, so you can make it 0, you can make it 1, you can make it 2, you can make it 3. But you can see that if you increase this 9 to 0 and make it to 1, means you can do here, then you can do here. So you got here and you have this also here, means you got a contiguous subsequence. Note this word, contiguous subsequence, means they don't want to found your subsequence, they want you to get a contiguous subsequence in a minimum operations. So what the first thing you have to think in your mind, so see these kinds of problems generally, like the minimum operations, you can solve with the help of dp, right? But at this problem you didn't need that, because the constraints are too low. If the constraints are high, then we will think about. But okay, so what you can do is you can simply like add this and then add this, so then you can like get these values. Okay, so right now the first thing you should think in your mind that what they want is you have to make t complete substring of s. Means t, means if you have this your as s, and if you have this as your t, so what you have to do is either t will equal to this part, either t will equal to this part, either t will equal to this part, either t will equal to this part. Means what you have to do, you have to take this t and compare to the each block of that part of s. And what you have to do, you have to just calculate the minimum amount of making this part to exactly equal to this part. And what that part will help, like what the value will give you have to extract them and you have to take for all the minimum, right? And what the complexity will going to take, because you are taking t and you are iterating for each string, so the complexity will be t into s, which is nothing but 100 into 100, and that will like easily acceptable. Okay, so I think it's also a brute force, but I had code this, so I'm like explaining you in my code. So this is the code. Okay, so here you can see, so basically I had taken the input of string a and b. I had declared the answer, which is like too long, and what you can see is int I equals 0 while I less than n minus m plus 1. Because see, if you have like I will be the like pointer will which move in the this string. So when we compare this with this, So we want that now we compare this string with this part, right? Means I equals to 1, now equals 2. So now compare to 2 to this part. But we never want, suppose this string has a length of x, okay? So we had suppose, and from here to here in this string, suppose this distance is also x. Means now this is the last part where we can compare, because this also has x and this also has x. So now we can lastly compare them. So we don't want to get to extract this part, right? Else we access a index which is not declared. So we get runtime error, okay? So that's why I just made this n minus m plus 1, and now your n temp equals 0, just like to store the answer, okay? Then I x equals to I to increase the ith for like iterating on this, and j for iterating on this. And like it is very simple if you like know this template, not 10 template, simple coding. Else temp plus equals to 10 minus bj. Okay, so one thing, suppose when you have 3 and you have 7, so like suppose you have this and you have to make this, so you can simply see 6 minus 3, and in character their ASCII value will give you the 3. But when you have 6 and you want to make 3, so what will happen? You first make 7, then 8, then 9, then so on. So what you can do instead, 10 minus 6 minus 3 plus 1. So these are things you can just sorry, plus 1 not only this. So when you like do this in the copy or the pen, so then you will going to figure out this. So this how you will solve this problem. Okay, so I hope the explanation of this question is also clear. So now let's move to the next question. C1D Popoyo. Okay, so the problem saying is that you have an integer array of a of length n. What you can do is choose an integer k between 1 and mod a minus 3, and what you have, like these all indexes are same. So what you can do is you can remove all the indexes, and that's all stuff, okay? So you have an integer like sorry n, and then something kind of stuff. So what you can do is um, you have this. So when you got all four indexes having the same value, you can remove them, and then you again got these four. Means you have like sorry one array r 1 1 1 4 4 4 1, and then you have 2 3. So when you remove this, see, when you remove this 4 4, I think there's a 1 4 4, yes, 4 4. So now you only have 1 1 1 and 1 and 2 3. So again you can remove this, and when you remove these 3, you only left with 2 3, and you have to only you have to only print the final value of 2, the final value of the string, which is 2 3. Okay, I think my voice is ready, my voice is recording. Yes, okay. So I think you got the question what they want to say. So first of all, what the approach like should click to your mind. It's something like when I was solving this problem, so it simply remind me this problem. If you like had encountered this problem, then it encountered me like things about me, like you know the stock stack problem, famous stack problem, where you have to make a stack and you put this, then you have this, then you have this, and then you have this. So basically the stack famous stack problem it is. So where you keep inserting the values till you get something, and then you will like do whatever you want according to your problem. So here it is just a simple variation of this. So what you can do is, if you I hope you know the stack, and if you don't know, please search the stack and read any GOG article. So see what will happen. You have 1 1 1 4 4 4 4, and then you have a 1 2 3. Okay, so what you can do is just keep inserting 1 1 1, and when you got 4, keep inserting it, keep inserting it, keep inserting it, keep inserting it. And when you got the first time, when you know the this index, like this index and this index means the last four values are same, remove 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 remove, and then keep inserting, and then you again got that this is same, remove 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 remove, and then just put 2, then put 3. So you know that now you cannot do anything, so your simple answer will be 2. So these are like simple implementation problems, okay, not so much heavy. That's why I'm saying that this contest was easy. Okay, so now just see that what I did. So basically, if you look at my code, what I did is int and cin and vi vacant. So basically you can take the input stack for auto stack dot push I. So what I did, basically take the value, just put the value, take the value, push the value, just make a vector to keep a track of these all four indexes we put. So what I'm doing is j less than equals to 3, because we have to check the stack last four values. So 0 1 1 2 and 3. So these are the four values we're going to check for, like for each. and you don't think about the time complexity, because we are just doing the like removal of last three elements, so it will be 3 into the n. So you can think about it, there will not any time complexity issue. And this is simply, suppose that I have only these elements, so I cannot like access four elements. Okay, so that's why I'm just keeping make sure that I hope I have four elements, then only I will do the operation. So now I have the last four elements in my temp of the stack. And now what happen, if my temp have a size of 4, means I have 4 elements, and this condition is happening which is mentioned in the question, so definitely I can continue. Else what I can do, I will simply like suppose now I don't have that 4 elements, I have only 2 elements, so I can't move them, right? So just what I can do, I can simply again insert in the stack. So just again insert in the stack, and at the end you just have to print the size of the stack. So this is again the simple problem, you can solve this in the simple steps. So I hope like my explanation is like proper to like helpful for you, and it is also understandable. And if it's like looking fast for you, so please mention me so that I can like uh, change according to that. So let's move to the fourth problem. And the fourth problem was again easy, not that much hard. So the problem is like this is, you can read, you have array a b c, you have to just do this, means you have ai bi and ci. So you have to take some values from a, some values from b, some values from b c, and you have to maximize the sum. Okay, so you have like this, I'm explaining with the help of example. 1 4 2 4 3 2 3 4 2 2 3 2 4 4 3. Okay, so now see, right now you have this one. Okay, so what you have to do, suppose you are thinking to go like take an array from here to here, then you cannot pick this element. Or suppose you are thinking to go this only this element, then you can go here, means you have to take an element from like x, and then you can take from 0 to x till here, and then you have to pick a y, and then you can pick from x plus 1 to y in this, and then you will pick from y plus 1 to n in this. Okay, so I hope the like the problem is too straightforward. So basically this here, and you have to maximize this value. So definitely when these kinds of question is coming, you have to maximize the sum, something kind of thing. So you first of all try to think, can you solve this with greedy? Why I'm saying this, because greedy will mostly in the case greedy will not work, right? Because there you can't do sorting. When you have, when you can't do sorting, mostly like the greedy things not work. So right now, can I do dp, can I do dp? So first of all, the brute force approach will be, the brute force approach will be, you just have to pick two values, right? X comma y. So can I like take all values for x or all values for y? So the first thing which came in my mind, so I'm feeling like that. So but you can see x can go from 10 to power 5, and y also can go to 10 to power 5, so you cannot do this, that will be TLE. So what I can do next, so when you do, when you think this, the next thing which should come in your mind, that this is a standard DB problem. Okay, so what you can do is like if you think, like suppose you, this is a grid. Okay, so if this is a grade, so suppose you are thinking to take this and this. So now tell me, now you are thinking to not go forward, so now what you can do, if you want to come down, you have only two options, like you have only one option, you have to take this element, right? Or suppose you just want to take this element, you don't want to take this element, so then you will take this element. So what my point is saying is, if you are at this element, so either you had came from this element, either you had came from this element, try to think, either you can take this, then this, then this, or either you have taken this and this and this. So if you try to write a simple solution, like simple DP recursive solution, or the transition state, suppose this cell is I comma j. So DP of I comma j is equals to DP of I minus 1 comma j minus 1, या तो ये ले लेंगे, means either we can take this one, or else we can take dp of I j minus 1. That's all. You just have to take the maximum of both in the each cases plus the vec of I comma j, what the cell is. So you can like simply code this. I like this is a simple problem. uh, but I did in some different manner. Like you can also implement it using BFS. Like you can just start the BFS from here and relax each node if you think it like the node. So you start BFS from here and you can just simply relax each node. When you're going here, then you are like, suppose you're going here. So if you can relax this node, relax this. Relax means suppose you have suppose 0 and you can reach, suppose this is a node and this is in this node, you have suppose value some x, but in BFS, you find that you can also need reach to this node with some suppose x plus y. So definitely you will make this node to x plus y, and I'm using BFS that was standardly known as Dijkstra. Okay, so you can, that's Dijkstra known as. So basically, I was like, when I was implementing that, I did this with Dijkstra, and that was MLE because this line. I was like thinking why it is coming like MLE, but I'm showing you the line. So you can see that vector n and then vector m. So this line giving me MLE. I cannot do MLE. I cannot make n cross n because that will take a huge space. I have to make it 3, so that this will be 3 into n, and that will be acceptable. So what you have to do, simply I'm just explaining you, like the DP process is straightforward. Just initialize the DP, and for each cell just compute this one, and then you can just simply, but if you want to see my DBF solutions, then you can see here what it is. You can simply take the input Dijkstra, you can call, because that algorithm is known as Dijkstra. So some standard things, pair function for the direction. So suppose I am at this cell, so I can go to 1, means I can go to 1 comma 1, or I can go to 0 comma 1, right? So these are the direction where I can go. And so you have a check function, and then this will tell you that you are in a grid or not. So then the extra, just make the answer where we can store the values. Then you have a queue push, just initialize the first value so that you have like the source of relaxation. Then you just have like queue, then you just parent x, then parent y, then every time pop, so that you don't have infinite loop. Then child x, child y, checking child x, and then you can relax it. If you can relax it, just do the relaxation, queue push in the queue, and that's all. So this how I did this solve problem. I did this problem, but I suggest you to solve this using that DP solution, because that was too straightforward. First time I did with that, but I have explained you that one also. So I think it's 17 minutes and explained you fourth problem. I think the pace was like fast, but please tell me if you think that it was good, then no issue. But if you're thinking that it was fast, then I will like did this slow. Okay. So, and sorry for my bad English. So right now the problem is statements, heavy buckets. This was again a too straightforward problem. I'm telling you, like first of all, I was also not able to think like this problem can be like that too much it's straightforward. But yes, so first of all, I'm explaining you my approach for this problem. So the problem is, you have n people and n buckets. So you have like person I holds only bucket I, and bucket I is empty. For now on, the following operation will be performed 10 to the power 9 times, which is quite long. For I equals to, simultaneously per person I adds I units of water and a lot of stuff. I'm explaining the problem. Okay. So see, you have 5 6 3 4 2 5, means you have 3 4 2 2 5, 1 2 3 4 and 5. Okay. So what is happening here is, suppose query is 4 3, means what you have to do is, you have to start from 3. You have to start from 3. So first of all, what the scenario is, one, like every ith guy have ith bucket. So right, initially the third person have the bucket have 3. Okay, means the, like the bucket filled with 3, something kind of that. Means 3 or 3 units of water. So right now the bucket hold by this guy, which is third guy, having 3 units of water. So initially what will happen for the first operation, wait, okay, so for the first operation, this guy will credit you 3 credit, because this have a bucket which is having 3 liter. Then what will happen on the second operation, like the bucket filled with 3 means 3 plus, now the bucket will transfer to second guy. Okay, now the bucket will transfer to second guy. What the second guy will do, second guy will simply fill 2 liters of water. 2. Okay, then the bucket will transfer to 4. how much bucket, again the fourth will fill 4 liter of water, then the again it will transfer to 2, and then again to 4, means it's like infinite loop. So 2, so you just have to tell the answer for fourth. So you just can see that 3 plus 2 plus 4 plus 2. Okay, so it means that answer will be 11. Okay, so now first of all, the first thing which you have to observe, that whenever you have something like I, and then you have to go for a of I, and then you have to go for a of I, and then you again have to go like a of I, something kind of thing. So you should have to go for graphs. Okay, so now if you try to think in this graph. So you have a graph like this one, so I'm drawing here. So like think it like a directed graph. So you have a node from 1 to 3. Okay, 1 to 3, and like you can go from 1 to 3, then you can go from 2 to 4, then you can go from 3 to 2, then you can go to 2 to 4, which is like again the like 4 to 2, which is like this, and then you have a separate node 5. Okay, so what is happening here, you have a node from 1 to 3, 3 to 2, 2 to 4, and 4 to 2. So what I was thinking, when you make the graph, I think I did made okay, this was 3 and this was 2. Okay, okay, so suppose if you have to start from here, this was approach 1 which I was thinking, and I was spent like something 130 hours to like think this. So what you can do is, first of all let me clean this. Okay, so if you just think that if you got inside a cycle, then I think you don't have to iterate, right? Because if I say that you are here and you have to do 10 operation, and you know that in one operation you got 2, then the 4, then 2, then 4 4 2 4, you simply divide it and you will got the answer, right? So what you can do is, you can simply like 1 then plus 3, and if you got inside this cycle, then you will never come back, right? So then you will like, okay, I know the result for my cycle, and if I know the result for my cycle, I can simply evaluate that and simply divide it and I will get the answer. But now the problem is that maybe there are multiple cycles in the problem. Okay, maybe the multiple cycles in the problem, but the scene is, you just have to like these graph is known as functional graph. Okay, and the like property of functional graphs, you can also observe not only property, like if you have an index 1, so it can connect only to 2. Suppose there is a value, suppose y, so there is a node from 1 to y. Okay, now one cannot have any another nodes, right? So this is the property of functional graph. So what I was thinking is, suppose with the help of DFS, I can calculate what these values, like suppose that for this one I have 1, then like first of all I was thinking that make this graph a DAG. Okay, DAG means, DAG today's cycle graph, and just compress this node to 6. Okay, now you should know what is DAG, what is STC, what is Kosaraju, something kind of thing. So that you can compress this node S6, and then you can find the topo sort, and then just start the when you have this topo sort, so just start the DFS, from the from that node which is have least topological sort. Means when you do the topological sort, so what the value which have very high degree of height in degree, you can start a DFS from that point. Okay, so that you can get travel all the nodes. Okay, so on that, what you will do, you simply start DFS from this. In this case, suppose you have this and this, so you will go simply got the value for, like, suppose this is 6, so this is 6, this will be 9, and this will be 10. So suppose you want to distance from this to this, you can simply delete 10 minus 9 plus 3, because you have to just include this note. So 10 minus 9 plus 1, this will give, sorry, plus 3, so this will give you 4. So which is like fine, because if when you go from 3 to 1, so it will simply give you 4. Okay, that I was thinking. But the problem here is, which I think that you will like figure out when you thinking that when the like the node is inside this cycle. So like cycle, suppose cycle is too long, so you should know what the value from here to here, what the value from here to here, what the value from here to here. Means you should know the answer for this one also, maybe from this one also, maybe from this one also, maybe from this one also. I know I'm not saying that is hard. So that is like you have to again run DFS for each cycle. Means you have to know DFS for each cycle. Okay, so that you can just get what the value you will get from here to here and any part. Or then you next have to calculate is your current node is any cycle. Means your current node is any cycle or not, because if it is a cycle then you have to think something. Because if it is a cycle, you just have to find that cycle and you will simply see how many operation it will took to like land on that cycle, and then how much it will like gain on that cycle, right? So these two things you have to calculate, and these makes its implementation hard. Okay, so that's why I didn't code for this, because like this makes its implementation messy also. And when after making this SCC graph, making this is making that DAG, you also again have to uh, keep the track of the previous graph also. Because when the user gives, suppose you have the maze cycle and user give you this, so you can't, because when you have this a single node, so you can't judge it, right? But when the user give you this node, so you should also have to take from the previous graph. So that makes its implementation hard. That's why most of the like the top coders I had seen and my friends also had seen, that's all using the binary lifting. And the binary lifting was simply the, if you solve it using the binary lifting, it is just simply the implementation of binary lifting. So what the binary lifting is doing, so I hope you know the binary lifting. If you don't know, you will not get this, so please go on the internet, search binary lifting and read the blog. So what is happening in the binary lifting, suppose I have a tree, I'm just giving you the quick uh, overview. And if you want, if you suppose if you have the tree and you want to get, for this node, suppose you want to get the fourth node, suppose you want to get the third node. So what you will do manually, go here, go here, go here, so you will simply go. But if you have a tree n nodes, so for each query you have to do n operations, so you will definitely going to do here, do that. So instead of that, what you can do is, suppose you have to go for x, just break into the binary, break into the binary, and suppose you have a binary number, and just try to think that to complete that number, you just have to fill these binary numbers. And that the binary lifting did. If you like, if you just confused, please read the read the tutorial or something. So like that is a standard problem. And if you know the binary, like the standard like stand standard, what I'm thinking, standard transition for that, so dp of I j, means what I'm first of all I'm explaining you the what they want is. So what you have to do is, basically you have a t operation, okay, that we going that we definitely going to perform. And then we have a node, okay. So what we going to do is, we will keep two things, we will pre-compute two things, which is first of all up or distance, and the next thing is water. Water means what the sum you can get, or you can say sum. Means what the value is, suppose I am saying you up of I comma j, means this means that what the value you will get, what the value you will get for the ith node, for the ith node, if you jump j times, if you jump j times, means if you have suppose suppose you have a tree, means suppose I have a value 4, okay, suppose you have 4. So what I'm trying to say is, if you have 4, so simply you will break into the binary, which is simply like 100. And then instead of looking at this 4, you will simply see like you have 4, so you just have to perform this, which is like 2 to the power 2, means you will simply invoke this times, you have to just 2 square, you have to go times upward. And on that you will know that when I'm at this node, when I'm in this node, and when I go to 2 times of this, so not think about like you are going 2 times, you are, this is in the binary, right? So what the value you will get, what the value you will get, and simply you will look it into that, and the sum you will also calculate that, and this all with the help of binary lifting. I'm showing you the code so that you cannot so that you can understand. Sorry, my submissions. This is the problem. Okay, so see, see. First of all, I had like wrote the basic observation I have, but I I think like that was not uh, easy to implement. So then I thinking that how someone can do it in just 20 minutes. So that means there's a solution exists which is much easier than that. So that's why think about bind lifting. Like see, I didn't think first of all bind lifting from my side. I see some codes, then like it's bind lifting. So simple. Okay, so first of all just make vectors, then you have like up dot sign, then you have sum dot assign, so you can simply 32 because what I'm trying to say is here you can see the 2 so that will be your I, means you have I will be the 2 to power k, so k will be your I, means 0 1 2 3 4 5, means when we are doing the 2 to power 5 jumps, 2 to power 5 jumps, so that is representing 5. Okay, and j is simply the node, so that's how you can see. So when it simply means when my fifth node, when my jth node doing 2 with power I jumps, so what's my value, what the sum I will get, so I will keep a track of both values. So you can see I have up means what the like when I'm doing the jump from here to here where I will go, and what the sum I will achieve, so both I will keep track of. So you can simply see what the sum I will get, like what the values I'm getting. So for n equals to 1, I is equals to n I plus plus. So this is the basic condition, means just try to think you will, this is very easy. So tell me, 0 means don't think it's 0. 0 is something like if you do 2 to the power 0 is equals to 1, it means when you did the first operation. So this is first operation. So after doing first operation for each node where you are, means where you will, means when you do, means if you look, if you remember the array, suppose this is the array, after doing for 2, if you do the first operation where you are at the 4, so that's why I did that. For after doing the first operation you will be the at index where the which is given in the input. And for what about the sum, after doing the first input you will doing to get 2 in the bucket, right? After doing the, suppose you for the fourth node, when you're doing the first operation you will simply get 4, for the fifth you will get 5 because you're doing the first operation, and you know for each I you will get I simply. Then this is the base case, and you simply by lifting of n, and which is simply like just give go for each 2 to the power k jumps, and for each jump just fill the values for each node. So that is the standard binary lifting transition up of k of I. Up k minus 1 means up k minus 1 means this is separate and this is separate. Okay, and the sum of k of I is equal to same transition, you can see sum of k of I minus 1 and up k minus 1. Okay, so this is the same transition you have here also. So now just go here and answer into maybe int I 0 I less than 32. If basically I was checking, like we are just decomposing that number into the binary. Here we have this query and here we have that node. So a and 1 less than I means just checking the and of that bit, that if that bit is set, just go here and answer plus equals to sum of ib, because that bit is set means we have to take that number, and just b is equals to above by b means move to that value also, means suppose you have 4 and after suppose 2 to the power k operation you go to 5, just set now b equals to 5. Okay, so that we did and simply print the answer. So this is a simple binary implementation version. So the whole point is, if you know the binary lifting, you can solve this problem in just 20 minutes, because these templates are like copy paste, that's nothing. And from my side that's all. Like the problem was, I was a was very easy, b was very easy, c was like both are implementation, d was a quiet and very easy flavor of dp, and e was something, if you know binary lifting you can solve this problem. So that's on my side. I think okay, that's all from my side. Thanks for watching. If you like the content, please do subscribe, and from my side, happy new year from advance. And uh, like in recent days I was like inactive in the competitive community, but right now I will be active in cf, lead code, atcoder, code chef, and whenever I have time I will surely upload the video. Just do tell, like just tell me in the comment section, did you like the content or not. and what the things I have to improve. That's also that will help me to learn. Okay, so that's all from my side. Thank you.